So for the next hour or so, we're going to go through some of the basic syntax of WDL workflows. A lot of this material is drawn from the WDL web page that Geraldine's group has put together. Okay, Kate has put together. And so a lot of the diagrams that you see in our slides should be familiar to you. And that's a great resource for learning the basics of the language. And we're also going to touch on aspects of the language that are particular to its use within Cromwell and FireCloud, and in particular the use of the runtime block to specify runtime parameters for your tasks, and some of the design decisions you have to make around the setting of those parameters, whether they're hard-coded in your WDL or whether or not you want to expose them as parameters that can be set through the method configuration. Okay, as it's already been mentioned, the WDL, or the Workflow Description Language, it was developed at the BroadE. It's used by FireCloud, and it's also used by the genomics platform here at the BroadE for doing all of their sequencing pipelines on the cloud. It was designed to be human-readable, and it makes it easy to describe tasks, chain tasks into workflows, and run tasks in parallel when those tasks don't have any downstream dependencies or upstream dependencies. Okay. As we said, Cromwell, the FireCloud's workflow execution engine, executes WDL scripts, and as you've seen, you can run it outside of FireCloud as well as it running within FireCloud. These are links to WDL resources. As I said, there's a great WDL user guide. There's a WDL forum where you'll see a lot of sort of questions or discussions amongst the WDL designers and the people who are using WDL. And also both Cromwell and WDL, there are publicly available GitHub repositories where you can get information to. Okay, as you've seen with the Hello World application, in WDL you describe both tasks and workflows. Again, a task is a description of an application that runs in a Docker container. You declare inputs and outputs at the task level. You also describe a command line that launches the application, or it may be a series of shell commands that you run within that Docker container. As I hinted briefly, you also specify runtime parameters in the task level WDL description. And this describes essentially the kind of virtual hardware environment that you need for running the task. Yes?
Is there one Docker container per workflow?
No. There is one Docker container per step in a workflow.
Step per task.
Per task, right.
So if I have multiple tasks that use the same Docker container?
They can use the same Docker container, but you don't have to use the same Docker container. So you can have containers that would be, if you put all the tools into one container, you have tools that are compatible with one another. It solves that problem. Like this tool needs to use Java version 1.1, and this one needs to use Java version 1.7.
Yeah, definitely, yeah. But so is there additional overhead to having, like, does the task spin up the Docker instance each time?
Yes.
Each task equals one VM.
VM. So really, they can use the same Docker image, but each task uses its own container, instantiated container.
But it's also already downloaded. So is there additional overhead to like having multiple commands, asking for a Docker image twice that's identical or not?
A lot of this stuff is like things with buckets, stuff with pulling Docker images is just a lot of Google magic that makes it so it's not really a problem.
Okay, that's fine.
But they seem to cache things somewhere where they can pull it more quickly. I don't know exactly what goes on, but it never seems like that's never really the source of much overhead. You usually find it in other parts.
Yeah.
It is overhead, but it's negligible compared to most.
Right. So we are relying on this Google Genomics job execution service to spin up the virtual machines, load up the Docker images on those containers. Yeah. Yes?
And do these tasks also allow for linking multiple containers?
For linking multiple containers? No, you would go ahead and download one.
Like a multi-processing thing here?
Yeah, just basically, like normal kubelet would have basically multiple containers linked together as a single application.
Well, that single application would be the WDL workflow.
Wait, are you talking about composing multiple
Yeah.
Docker containers together? No, it doesn't allow you to define like a composed
Okay.
container. You have to define a container that you have done the composition
I see.
already.
Within the WDL, you also define a workflow. That's a collection of tasks and the wiring of the tasks, so to specify what outputs from one task are then wired into the inputs of a downstream task. Okay. The base structure of WDL, we'll be going into this. There's a set of 3 top-level constructs. There's a workflow, a call, and a task. Within a workflow definition block, you make calls to sets of tasks. Within the task definition blocks, text definition blocks are in the same WDL file as the workflow definitions, but outside of the workflow block. Right now, we don't support, if you have a WDL file that lists a series of tasks, you also have to have in that same WDL file, you have to have the definitions of the tasks as well. Eventually, we plan to support importing, so you can just go ahead and import the task level WDLs, but right now we don't support that. Okay, the call dependencies and thus the order of execution are going to be determined by the wiring between the tasks. It doesn't really matter what order you actually write those tasks or write the kind of call statements within the WDL itself. Cromwell will go ahead and see what the dependencies are, generate its DAG, and based on that, it'll go ahead and determine what can run in parallel and what downstream tasks are blocked by upstream outputs not being available. Okay, so let's look at some of this here. Okay, you have this is a WDL file. You specify a workflow definition block. You say the workflow, this is my workflow name, and then you just have a series of calls to tasks. If you look inside a task definition, you'll see these blocks right here. There's going to be a command block, an output block, and a runtime block. In the output, in the command, you go ahead and specify the actual one or multiple commands that are run within that Docker container. The output block, you explicitly declare what the output files are going to be, and the explicitly declared output files are going to be written back to the Google bucket. They're going to be delocalized. And the runtime blocks, that's where you specify the unique identifier of the Docker container, or the Docker image that you're running, and things like the number of CPUs that you need, the amount of RAM that you need in your virtual machine, the amount of attached disk that you need to that, and the boot disk.
What would be the default if I didn't specify memory and things like that?
We're going to be going through that.
I have a question.
Yes.
So there's always this issue of these intermediate files that take up
Right.
lots of storage. Do they, by default, do they just stay there, or do they? Is it like pipes? It's gone.
Well, okay. It depends on whether or not those intermediate files are explicitly declared as outputs. If they are explicitly declared as outputs, then they're going to be written back to the bucket, so that they can be used then by downstream tasks.
Then they stay there.
Then they stay in the bucket. Yeah. Right now we don't have. We've talked about having a means of clearing out intermediate files, but right now we don't have the ability to do that.
Can you offer some guidelines on granularity? So what I mean is, suppose you already have a pipeline that runs outside of FireCloud.
Right.
You're trying to put it in FireCloud. The pipeline has multiple steps. Instead of redefining each one as step, maybe you just want to declare, go run the pipeline.
We actually do that. We actually have a PCOG, a pipeline for a pan cancer analysis, and it was written using a workflow description language that Gordon wrote called Pipette. And what we did was we went ahead and sort of packaged that into a single large container. And that's how we go ahead and run it in FireCloud, where we go ahead and wrapped it up as a single whittled task. And it runs on a very large machine with lots of CPUs, and we run the entire workflow that way.
My
And the whole
recommendation,
thing's in one Docker.
Right.
my recommendation to start is usually to do like one task whittles. You know, you just get it running at first, and you can figure out about optimizing it later and
Yeah.
stuff like
Right,
that.
right.
You're not gonna get a huge amounts of gain unless you're scattering and gathering within the whittle. You just wanna run it, you can just make it into a whittle and just run it.
Yeah.
I mean, the other thing to be keeping in mind is around versioning. If you have a whole pile of tools in one bundle, you want to upgrade one, that means you have to upgrade the whole bundle. That could be good or bad, but in.
Okay, so maybe that's the driving principle between granularity is that if.
Yeah, if you have 100 things in one, then okay, do you really want to release all 100 when one of them gets updated? Maybe yes, maybe no.
Okay, yeah, yeah.
Does this make a reference to like a nested whittle? Where you launch a Docker and that one Docker, actually, I'm trying to figure out how this actually works. Like how would you define the workflow inside that one Docker instance?
Well, it would be run on that single VM. So it's
So basically you have a whittle that runs the command on a node, right?
yes, and the code in that node has its own workflow execution system
Right.
built
Or it
into it.
includes its own cromwell and its own.
Not necessarily, and anyone, but I don't think it can launch additional VMs.
Right. Yeah.
So it all needs to run on the same machine.
Gotcha.
Yeah.
Okay, Alex, aren't they setting things up where one node can launch additional VMs or?
I'm not sure what the status is of that.
Okay.
Yeah. We're discussing doing something like that to support Spark workflows. We'd want to launch a Spark cluster. Yes?
So it works today with Docker anywhere, either on Google or locally or anywhere else you have Docker running?
Yes. Well, it's at the individual task level. A task runs in a Docker container. You can run that task in any environment that supports the running of Docker containers.
Yeah, so if you run cromwell locally and you give it that whittle, it will actually spin up. It'll spin up those Docker containers on your machine and run them on your machine. If you can also run cromwell locally and point it to a cloud backend, and it will run it in the cloud, which is equivalent to what FireCloud is doing. It's just that you have to manage running all of those tasks. You don't get any of the kind of benefit of the data model or monitoring things that have been launched. But it's all compatible running on your machine. So
And
it's really
and you need someplace to run cromwell. On a VM or?
You can do it on a VM or on your own machine. Depends on what makes sense for you. I mean, you run it on your own machine when you're debugging. It's helpful to just test it out with a local cromwell.
Yes, but in production you'd expect it to be on some BroadE.
Yeah, yes. And if you write a workflow that does very wide scatter gather, I've personally done that on my laptop and it's not been very happy. So,
Okay.
in the real world, it will spin up a VM for each one of those. Not 10,000 threads on your machine trying to all do something.
Can you run a local version of Cromwell and have it make calls into Jez?
Yes.
Okay. All right. Okay. All right. Let's look at the task level definitions here. So we're expanding it a bit. We're defining task A. Here we explicitly declare what the input files are, what the inputs are. And these inputs can then be referenced in the command line string. through this notation, $, curly brackets, and the name of that. And then you can also go ahead and specify those input parameters as part of your output file. So for example, we have an input as a string, it's an ID. We can incorporate that into the name of the output file. Okay, at a workflow level, you go ahead and also specify what the input parameters are to the workflow, and you saw that we did this in the Hello World application. So here we have two tasks. We have task A, task B. The input to task A is going to be, we're saying that it's getting this input right here, myref, and then input here, and then we're also getting this name right here. The input for task B, we're saying one of the inputs is going to be the workflow level inputs, but the second input is going to be the output of task A. And if we were to go down and open up this task A, we would see that one of the explicitly declared outputs is going to be out. So this is how you do the plumbing. This is how you specify a dependency of task B on the output of task A. It's pretty straightforward.
myref, my input, the name would show up in your method configuration?
Yes, what will show up in the method configuration is it'll ask for inputs, and it'll say, okay, there's a workflow level input. It'll be my workflow name.myref, my workflow name dot my input, and my workflow name.name. And the method configuration, you would then go ahead and bind those workflow level inputs to attributes in your data model. Yeah. Okay.
And can you bind them to anything else? Like
You can bind them to literals.
like a constant? Or?
Yeah, it supports literals, and also you remember we talked about workspace attributes. These attribute values that are associated, they're like global attributes that are available within a workspace. You can bind them to those also. Yeah. Okay, so we call this plumbing, the kind of plumbing or the chaining of tasks together. And you can chain tasks linearly. You can do lots of different sort of ways of arranging the plumbing, multi-inputs or outputs. You can do branches and merges, and you can do scatter gathering. And we're going to be demonstrating through some of our exercises, examples of linear chaining, multiple inputs, merging, and scatter gather. Okay, linear chaining, we already really saw an example of this. It's the simplest thing where you have an initial step, creates an output file. The output file serves as input to the next step, downstream step, and similarly into the final downstream step. And to create this chaining, as we already saw, in the workflow block, we say there's going to be a call to step B, and the input for step B is going to be set to the output of step A. And similarly for step C, its input is going to be the output to step B. Okay, we have a simple example of this that we can go ahead and run. And I'm not going to ask you to run it in FireCloud, so you won't have to go through the whole process of uploading it and creating the workspace. But if you want, you can go ahead and run it on the local cromwell. This is the task right here. Let me make this a bit larger. Okay, first we'll take a look at the workflow. In all these examples, we kept things really simple. We're not using bioinformatics tools. I just wanted to show you how to do the wiring and what the functionality of WDL is. So you can see that our simple tasks are adding numbers and multiplying numbers. It's nothing that elaborate. And also you can see, but here, I definitely got to figure out how to use this. Let's try if I can bring that up again. Okay. So you can just follow my cursor here. So you can see that we have, these are just serial tasks where we have initial task called add to task. It takes as input the workflow level input, then that's passed in the multiply by 5 task, and the output of that is passed into add 3 task. It's a simple algebraic operation. Let's take a look at these individual tasks. You can see that the command line here just contains a series of shell commands. We aren't actually, and so that's why the Docker image is just a base Ubuntu image. There's no additional software installed on this. And so here we just take the input number and add 2 to it. Here we take the input and multiply it by 5. And here we take the input and add 3. Nothing very terribly complicated. We can go ahead and test this locally. I'm going to exit from that. Okay. Just a little. So the first thing we're going to do is Java. We can go ahead and .bin/cromwell jar. Well, let's first go ahead and create the, we want to create the input for it, and you're going to do that by running the WDL tool. WDL tool jar, and I think you say inputs, and you give it linear chain.wdl. If you run that, you can see that it goes ahead and creates the JSON object for that. Let's go ahead and write that to chain inputs.json, and we can go and edit it. Chain. Suppose we go ahead and set it to 1. And then we want to go ahead and run it. So we're going to do a Java -jar little bin cromwell jar. I think it's run linear chain.wdl and linear chain underscore inputs.json. Oops, got that wrong. Yeah, a lot of output, but essentially what's happening here is it's going ahead and launching 3 of those Docker containers, 1 for each task, and the outputs are this goes ahead and provides also what these are the explicitly declared outputs, and they're stated right here in the final sort of result. Okay, so that's pretty straightforward. Any questions about that? Yeah. And I think, let's see where we are next. So, where are we here? Okay. The next WDL we'll take a look at is one that does task aliasing and merging. So in this case, what we're doing is we are running the same tasks twice. And we want to go ahead and the output of one of those instances of task, the outputs of each of those tasks are fed into a downstream step B. but we need a way of going ahead and sort of running the same task multiple times. And the way that we do that is through this construct as. So we say in our workflow definition, we call step A as step A1, and here we call it again as step A2. And then we can explicitly declare what the outputs of each of those steps are and serve them as inputs to step B. And I'm just going to, I don't think I'm going to bother running it, but I will just show you what the WDL looks like for that. Okay, so here's the workflow. Oh, did I do it again? Yeah. Just stop with that. Here's my. Okay, so you can see that here there are 3 individual tasks that are called, but we call the add to task twice. First as first adder and second as second adder, and we can go ahead and explicitly declare what those outputs are and feed them into this third task. And for this particular example, which you can run at home, it's once again all it's doing is just the add to task adds 2, and the add nums task just goes ahead and takes its 2 inputs and adds them together and writes them out to a text file. Okay. You know, clearly in your workflows, these will be replaced by sophisticated calls to various bioinformatics tools. Yes?
So I've noticed when making tasks that although you can refer between tasks to the output files, within a task you can't. So in this case, for instance, for your command add nums task, your output file log equals log.txt. You also write that in your command. It'd be really great to be able to link them together, just to be able to say, in the command, for instance, to be able to say add nums task.log there, so that you only update it in one place and you don't run the risk of
I think actually you can write your WDL to go ahead and do that. I believe. Eddie, is that the case? Can you? The question is whether you can introduce parameters.
You want to be able to have like variables.
Yeah, I want to be able to, for this case, I want to be able to say log.txt once so that I don't forget to update it in the command when I update the
I
output.
think you can actually. Okay.
Yeah.
I'm not 100% sure, but
I may have messed up in the past.
I'll see if I can get the answer to that.
Okay, now we're going to take a look at scatter gather. So this one we will actually run. So it allows you to take as input a array and run a function against all the elements in that array. So, or run that task multiple times against all the elements in that array, and the results will automatically be written into an output array that has 1 element for each of these scattered elements. And it'll spin up a separate VM for each scattered task. Yes.
So principally, you would want to have to only do that when these are long tasks or CPU intensive.
Yes. Right. Yeah. Yes.
So you said that this spin out a separate VM. Can it actually be container-based instead?
Can it be what?
So can multiple tasks run on a single VM, or it's just one task per VM?
There's 1 task per VM.
Okay.
Yeah. Okay. You know, and so we have examples where we have workflows where we will scatter them across the 23 chromosomes. And then aggregate the results. Okay. This is the construct that you use for doing that. You're going to declare within the workflow, you're going to declare within the workflow, you'll declare a variable, a array of files, say input files. And then what you'll do is you'll scatter, for each of the input files, if each of the files in that array, you go ahead and run step A. And then the output this in fact is going to be an output array of all the outputs from running each of step A. And that can serve as input to a downstream gather task. Yes?
What mechanisms might you use to send in a series of parameters?
I mean, an array? Okay, right now what we do is we actually set up an initial task that goes ahead and generates that array. But we want to be able to explicitly declare through the method configuration an array that you can input, but currently we don't support that. Like ideally, it would be nice if you were running something on a set, like a sample set, and you had a way of explicitly declaring an array that was generated from attributes of all the same type within that set.
That'll be fixed in a week.
In a week. So, all right, let's take a look at our scatter-gather example. Okay. And the basic form, I did it again. I should just learn my lesson, shouldn't I? Okay. There we go. Okay. Okay, so here we have, in our workflow, we have a initial task that's scattered across all of the values in a array that is generated by a prepare task. And then what we do is within that scattering operation, we call the analysis, and these are the results that are obtained. It's a string. And then what we do is we get the analysis.out. This actually is an array, and it's processed by gather. Let's take a look at what these individual prepare, scatter, and gather, prepare, analysis, and gather tasks are. So in this one right here, for the prepare task, as I said, we just have this task generate an array. And then what we do is, for the scattering, really what we're doing is, well, I guess what's happening here is, that the output for this is going to be an array, which is going to contain the elements of each of these lines. So it's going to be 1, 2, 3, and 4. The next thing that we want to do is we want to run the analysis on one of those strings. And the analysis is just going to go ahead and print out that string. And it's done through this operation where this is the output of the prepare step. It's an array, and we just call analysis for each x in that array. And finally, for the gather, the output of the scatter operation is going to be an array. We go ahead and receive that as input, and we just go ahead and echo the contents of each element of that array. And what we're going to do here is we're going to go ahead and run it within FireCloud, because what I want to show you is how within FireCloud you'll see the scatter operation. And so when we do the monitoring, you'll see that you can take a look at each call, and you'll see that there are going to be, in this case, 4 calls associated with the analysis, because we're scattering 4 ways. and you'll be able to see that. So let's go to FireCloud. Let's see if we can maybe, let's see if that workspace that we created before the Hello World workspace is now healthy. Wait, wrong workspaces. Okay, let's see. Okay, good. It looks like that problem with not having access to the bucket has been resolved. And so now we can actually see that if I was going to go ahead and click on the bucket, it would bring up the Google Cloud Platform Developers Console, where you could actually look at the contents and browse the contents of the bucket. Right now, the bucket is empty. So what I'd like to do now is we're going to upload some additional data to this. Let's go import from the scatter gather. I'm just going to import this particular participant. Looks like it's the same ones that I already have. So probably it didn't duplicate it. It just recognized that these already existed and overwrote the data. And we have a single participant set. The next thing I'm going to do is to import a method configuration associated with scatter gather. Oops. Method repository. Here it is right here. And this method is available to all of you. I made it public, so you should be able to do this. It's scatter gather example. And we're going to go ahead and export it into our workspace. Go edit, import. That's new. No, stay here. What happens if I click yes? Okay, there it is. Okay, now what we're going to go ahead and do is you can see that this particular WDL input, the scatter gather, it didn't take any inputs at all. So there's no need to explicitly declare any inputs. We still have to, in order to run a workflow, it has to be targeted at an entity. And so that's why we still have to specify that the root entity type is participant, but we aren't going to be taking any input from that entity. But we are going to go ahead and write the output back to the data model. And let's just say we're going to go ahead and write this dot scatter results. Okay. And now we're going to go ahead and launch it. And we launch it at participants. That's interesting. What workspace am I in? That's interesting. Hold on. I'm going to cancel this. Scatter gather example. All right. All right, we're just going to go ahead and launch it at one of these. No, I don't want to launch it here. I'm in the wrong workspace. I'm going to check the data. There it is. I'm going to run the method configuration for the scatter gather against one of these. We're running, and this is what I wanted to demonstrate to you. So we can go ahead and, right now, that job is queued. That single workflow submission is queued. Let's go ahead and refresh it. We can see now that it's submitted, so we can go ahead and drill down. And we take a look at the individual calls. There's a scatter, a prepare. I don't see where the analysis is. That's interesting. I don't know why it didn't show the analysis. Huh. Let me try one more time. Oh, I did it in the hello world. That's what I wanted to do it in. Here's the method config. I thought I had imported the scatter for that. There it is. Edit. This dot scatter results. Save. Now we want to launch it. We're going to launch it against one of these entities. Launch. It's queued. Now we can drill down.
So it looks like you have a prepare step. So do I understand correctly that the prepare step has to prepare something that is input to the scatter?
Right, and so maybe
the prepare step has to finish
before
you will see the calls.
That's right.
To the scatter.
Yeah.
And so the prepare, typically a task takes a minimum five-ish minutes.
Okay. Thank you. Yeah, that's what's happening. Yeah, I forgot about that. Let's see what's, well, if we click on the monitor task, my memory in the past was that you could see the...
You can see, but see, you see the gather though, even
Yeah,
though it has not yet run.
Right.
But the scatter is, it's a little dynamic, so it doesn't show anything until an actual call has begun.
You're absolutely right, yeah. Well, let's go back and visit this again in 10 minutes, and hopefully we'll then be able to go ahead and see the results.
Can I ask a question about?
Yes.
If you give some guidelines relative to multi-threading and whatnot. So suppose the task that you're calling is multi-threaded or is not multi-threaded, and I'm basically interested in understanding when you want to have something repeated and you would normally perhaps create multiple instances of the same process running somewhere on a virtual machine.
Right.
And how many you could start depends upon how many CPUs you had on the virtual machine.
Yes.
So where do you decide, okay, I want to have one virtual machine with one processor versus multiple processes on a single virtual machine?
It really depends on where you want your parallelism to occur. If you want your parallelism to occur at the virtual machine level, then you would express that parallelism through your WDL. And you would break out your task. If you wanted the parallelism to occur at multi-threaded on a multi-core machine, then you just have to make sure that for the runtime parameters for that task, you specify a machine that has a large enough number of CPU cores to implement the multi-threading. And I'll show you how we do that. Yeah. maybe in the time it took to answer that, we got we got this running. So I thank you if it did. Let's see. Yeah, great. Okay, so there's our analysis. And we can see that there's 1, 2, 3, 4 calls for that analysis. So that's where the scattering is occurring. And Eddie's right that you don't actually see the information on those individual calls until you've actually done all the scattering, because you don't, what?
The preparing.
Well, no, you have to complete the preparing, and then you have to launch you have to do the scatter operation. And when you do that scatter operation, that's when you can go ahead and monitor all the nodes that you're scattering across. And we can go ahead and these shouldn't take very long to run since it's a pretty trivial application.
Does the monitor automatically update itself?
No, it doesn't. It doesn't. You have to go ahead and refresh it by clicking monitor.
And speaking of nodes, I think Alex can confirm, but this ID operations slash stuff, that's the Google VM ID.
Basically, it's the Jess operation ID, which equates to one VM. So we have some power internally to check the status of what's going on with some of these VMs. We're going to push more of that reporting up to the front end.
Are there plans to make the monitoring sort of page update dynamically?
Yes, there's a lot of plans for a lot of stuff.
Right, yeah, okay. Yeah, you have to kind of understand that when we were developing, yeah, I know, we have a very large backlog. When we were developing this, the focus of this initially was being able to get it to operate at scale on the cloud. And so there are a lot of these features to improve usability that are just starting to go in right now, but we had to make sure we had to get the basic scalability, performance, and stability right first. And that's why you're seeing it's a little bit rough around the edges, but we will be making incremental improvements to the user interface and to the mechanisms that are required for building tools and testing tools over the course of the next 6 months. Yes?
Are there limitations on how many tasks can be run in a...
Could you, hold on, my hearing isn't that good, so I need to...
Are there any limitations on the number of tasks in scatter?
No, I don't believe so.
Okay.
Are there?
I mean, there's some practical limitations on like the number of virtual machines that are just available in a given region in Google, which we found out the hard way.
So let's say, just an example, let's say I want to run it on 720 cores. Is that normally possible?
On how many?
720?
Yeah, that should be fine.
Okay.
It's when you're in the tens of thousands that, that may be an issue.
Another issue might be your wallet too. How many virtual machines you want to pay for?
Well,
yeah.
Assuming those are short, then it could be.
Yeah, you're also limited if you choose a machine that is more rare. So like you want one that has local SSD and has 128 gigs of RAM and all this kind of stuff. There's going to be fewer of those machines.
Yeah.
So you should find out that just Google doesn't have it available sometimes.
Okay, so let's go back to the monitor page. We'll refresh it. The job is done. And if we go back to the data model now, and we see that the results was, if you recall, the results were a string where we just wrote to the string the value of each string in the array. And there it is right here. Okay. 1, 2, 3, 4. Okay. So that's a example of using scatter gather on FireCloud with WDL. The next thing I want to talk about is the runtime block. So you can go ahead and follow this link. Look on GitHub, on the GitHub repo for Cromwell. there's a good discussion of all the various runtime attributes that are supported. And because Cromwell runs both locally within FireCloud, and also it can run against, I think, Sun Grid Engine, there are different runtime parameters that are supported. And they go ahead and sort of show what the different values are. The runtime parameters reside in a block called runtime at the task level. I think you can also, I don't know if this is supported in FireCloud, but you can set, I think, runtime parameters at the workflow level, and they serve as the defaults for all the tasks.
It's not supported in FireCloud.
Yeah, it's supported in the language, but not within FireCloud. Okay, so in this case, what we're saying is the runtime parameter that we've been using a lot is the specification of the Docker image within Docker Hub. The second one is memory, CPU, and disks. And here it's multiple disks where you can go ahead and specify the various types of disk drives that you want and what their mount point is going to be. So in this case, this is, I think, going to be a 3 gig solid state disk, and this is going to be a 500 gig hard drive. The solid state disk tends to be faster, but it can't accommodate as much memory as storage as the hard disk drive. And I think also the solid state disks are a little bit more expensive. Okay. Yes?
Correct me if I'm wrong, but if you're testing on a local environment, it will ignore that Docker parameter?
Yes.
So if you're testing and expecting your tool to be available via the Docker, it'll cause issues.
No, if you're testing, it will still go ahead and retrieve the tools from Docker. But what won't be, there are certain runtime parameters that are not going to be recognized by your local version of Cromwell. And in the output, it'll actually display which runtime parameters are being ignored.
Yeah, I think that's right too, unless I'm misunderstanding. But I do know when you run it locally, you can not put the Docker in, and it will work, which won't work in the cloud. You can ignore the Docker part, and it will just use your local environment. Yeah. And I know when I put in Docker images before in the past, it actually does like the pull and running up locally on my machine.
Okay.
Yeah.
Is the memory a minimum or a maximum?
That is a minimum, I believe. You'll get at least that amount of memory.
And what happens when the application runs and exceeds it?
You run out of memory, and your application will probably fail. Yeah.
Then will you get some sort of message?
Yeah. Each task, it goes ahead and writes out to the disk standard error log, standard out, and also a log that's generated by the job execution service. And those will be available to you. Yeah, and so if you run out of memory, you'll probably get a out of memory message on the standard error.
Yeah, if you're running something in the JVM or most other applications, just utilize like virtual memory on the machine. If you're running out of memory, it's not like it's going to just die. But
it's going to start running really slow.
Okay,
but so that's what if you're unable to calculate precisely enough how much memory you need.
Yeah.
How do you get an indication then of what happened?
Right.
That's
a good question.
And then there must be a cost associated with chronically overspecifying. It's going to.
Yes.
Right.
Same as there would be with chronically overspecifying. So figuring out that perfect balance. That's tough.
Yeah.
Do we have any way of sort of generating a profile of resource usage on a VM while it?
No, but that's something that we've talked about.
Okay, is there a story for that? Maybe. Okay.
No, we just talked about
Maybe we should.
not a story for that.
Okay. All right.
I mean, you can kind of get that by doing the SSH stuff.
Right, but we don't have that yet. Yeah. Right. Okay. All right. So what I want to do is just run through some of these runtime attributes. One is mandatory for, this is for running within FireCloud. You have to go ahead and specify the reference to the Docker image. The next thing is a CPU. You can specify the minimum number of processor cores to use, and it defaults to 1. For memory, you can specify the minimum amount of RAM required by the task. And Jez will allocate a VM with at least that amount. And I'm not sure what the default number is. Alex, is the default value for RAM, is it 10 gig or no? Oh, it's 2 gig, I think. Yeah, okay. All right. And for the number of disks, I mean, for the disks that you want to mount, you go ahead and specify, you should claim that you want a local disk, and then you give the disk size in gigabytes, and then you indicate whether you want a solid state disk or a hard disk drive. Two? Okay.
If you were gonna have something that tried to calculate automatically what the memory was based on the input file size, would that go inside the WDL?
What you could do is if you had a task that did that initial calculation, then you could go ahead and parameterize the runtime parameters and pass it into the task so that you would determine what the memory requirements are from an upstream task, and then pass that down to the downstream task. So when it gets launched, it'll use that. I believe that should work.
There's no capacity for soft fail. If one of anywhere in your workflow, one of these things doesn't get enough memory and fails, then start over from scratch.
You'll have to start over from scratch, but we will be supporting job avoidance. And so in that case, any jobs that ran successfully and you try to rerun them again, if it saw that you're rerunning something that's already been run with the exact same inputs and the output's already available, then you'll just skip over that task.
Yeah, I also haven't used it, but I know that they do have some support in cromwell for like fail fast versus fail slow, and the thing you're talking about is like the fail slow case. It's only if you have parallel tasks that aren't dependent on one another. They can continue even though one of them failed. But it won't continue on a downstream task if that one failed, and then the job wouldn't be able to pick that up.
Is that fail fast and fail slow, is it exposed to users through
I think it is. I don't know enough about that feature.
Yeah. Okay.
But on a failure, would your VM just be destroyed, so it wouldn't really matter if you fell fast or slow, you don't get your outputs?
It depends on once.
It's not about that particular task failing slow or failing fast. It's about, do the other tasks that would be going on in parallel with it continue, or does the whole thing stop? Because the other ones could continue, the other VMs could continue and finish, rather than just being killed outright.
So if you don't have job avoidance, there's no point to fail slow.
That is true. So this is utilized right now by a team doing the genomes in the cloud work where they have job avoidance enabled. We don't for FireCloud. So we have to figure out how that works for FireCloud.
Okay. Another runtime attribute is boot disk size, and this is the amount of memory that you require on your boot disk that your Docker image is loaded on. So it defaults to 10 gigabytes, but if your Docker image is very large, then it's not going to fit on the boot disk using the default value of 10 gigabytes, and so you'd have to go ahead and up it. And we do this in our PCOG workflow. It's this workflow that runs, it's a single WDL task that runs its own pipeline execution service. It's a very large Docker image, and we had to increase the boot disk size to 50 gigabytes. And another option is preemptible. And this is kind of interesting. You can go ahead and tell Google Jez that you want to use preemptible virtual machines. And they're about a third of the cost of a standard virtual machine, but you can be preempted. And if you're preempted, that means that the work that was done on that machine up to the point of preemption is lost. But you can specify for this preemptible runtime parameter, it specifies the number of times the system requests the use of a preemptible virtual machine before it then goes ahead and requests the use of the full cost machine. So if preemptible is set to 0, that means that you're not going to use any preemptible VMs, and the system will automatically just use the more expensive virtual machine, and that's the default value. If you specify preemptible to 1, that means it'll initially go ahead and allocate a preemptible machine. If that preemptible machine gets through your complete task without being preempted, then you're in great shape because you just paid a third of the cost. But if you do get preempted, then because the preemptible value is 1, it means it's going to then go ahead and make a request for another virtual machine, but at full cost. Yes, Gordon?
Just FYI, Google dropped the prices recently, so it's now 1/5 of the cost.
1/5 of the cost, okay. All right. But if you are preempted, do you still end up paying for the time on that preempted machine?
You don't want to say, oh yeah, retry 10 times,
Right.
Probably
Yeah.
a couple times, and then just say, okay, here's the full price.
All right.
Oh, sorry, just a more general question.
Yeah.
How much is this relying on Google Cloud Engine versus if I wanted, let's say, to run the system on AWS? The FireCloud right now is very much sort of tailored to running on the Google Cloud platform. Yeah, and we would like to make the system cloud agnostic, but that isn't going to be happening anytime soon. I would just think that, if it runs on Kubernetes, for instance, then it can run anywhere. So that would be a plus towards.
Yeah, but as you saw from the architectural diagram, we leverage a lot of the Google services.
Okay.
Yeah. And you really have to make sure that you're running all in the same cloud, because once you can't run your analysis in an environment where you're moving files between cloud platforms. Okay, and 2 more runtime parameters that are interesting. One is continue on return code. By default, if the return code is non-zero, then the task is going to be marked as having failed. If you have a task that returns a non-zero return code, but it's still viewed as being successfully run, then you could go ahead and set this to true. Similarly, on fail on standard error, by default, if anything is written to standard error, then the job is viewing as having failed. The task has failed. If you go ahead and set this to fail on standard error, or maybe the default is false, I'm sorry. So the default is even if you write to standard error, it's not viewed as a failure. But if you set this to true, then if you do write to standard error, then the system will interpret that as meaning that the job failed.
So if you continue on return code and you don't fail in standard error, then you never fail? Or is there any other way to fail?
That's a good question. I don't know. I don't know. The question is, if you go ahead and set this up to continue on return, on a non-zero return code, and if fail on standard error is equal to false, then is there any way for it always is successful? Yeah. Yeah. Is there any other way that Jez communicates to the system that it failed, other than?
There would be failures of just localizing the data.
Right. Yeah.
But the job should probably just
be reported as successful.
Yeah, they would just float along and go full speed ahead.
Okay. Some of these runtime attributes you'd want to be hard-coded into your WDL. They're determined by the task, not the data. So for example, we talked about the boot disk size. That's going to be a standard value quite often based on the size of the Docker image that you're pulling down into the container. Similarly, the continue on return code and fail on standard error, that's going to be kind of hard-coded or defined by your workflow. It's not going to be dependent on the data. But there are parameters that
might change depending on your data or depending on your budget. For example, whether or not you use preemptible or the amount of disks or the amount of RAM that you have. These kinds of runtime parameters, you don't necessarily want to have hard-coded into your WDL. You want to be able to set them through your method configuration. And I'm going to show you how to do that right now. Yeah. Okay. And earlier we were talking about the ability of maybe setting them from an upstream task, yes. And I think you can do that too. I hadn't thought of that, but I think that is possible. What you would do is
something like the number of you. Okay.
Yeah. What you would do is you would have a task that sort of determined what the memory requirements were, and then you would feed that value into the task as an input parameter. The same way that you use the method configuration to specify what the input parameter is. Yeah. All right, so let's go ahead and take a look at this. Runtime attributes. Okay. What I did here was I put together a simple single task workflow. And the only thing that this task does is it goes ahead and prints out the number of processors, adds it into a text file, prints out the amount of memory, and also it goes ahead and prints out the kind of disk utilization. And you can see that what we have here is these are the runtime parameters for this task. We're saying that the Docker image is Ubuntu, but we're saying that the memory is going to be provided through this input parameter, this integer memory parameter right here. Similarly, the disk size is an input parameter, and the preemptible number of tries is an input parameter. Those parameters are also workflow input parameters, which means that they are going to be able to be set through the method configuration. And the workflow just goes ahead and calls that.
Can you set default values for those inside the task? Sure.
Yeah, I think so. Yeah.
Wouldn't you just do that at the variable definition, right? Where it says int memory, can you put equals, that would be your default value?
Can you initialize workflow parameters in the declaration? I don't know. Alex, is that possible? Does the language support that?
I don't know the answer to that.
Yeah.
Kate might know.
Kate, can you, when you have task level or workflow or task level input parameters, can you, if they're optional parameters, can you specify default values for them directly in the, you can? How would you do that? Would you say int memory is equal to, and with that value?
So you don't declare it when you declare the variable name, but when you use the variable itself, you use a $, open curly brace, then you say default equals whatever that value is, space the variable name.
So basically it checks to see if the input variable
Is
is provided.
defined.
Yeah.
Okay, I see.
And I added that to the documentation.
Okay, recently or it's, okay. All right, great. Okay, thank you. All right. So let's, this is the workflow. So let's actually go ahead and run this workflow. And I'm going to go ahead and run it in the Hello World workspace again. Let's go ahead and add some more data to this workspace. Runtime attributes WDL. So we're going to add a participant. So it's the same set of participants that I've been using, but I've added some additional attributes, so they should just turn up on this. And there they are. You can see that what we have here is I added an attribute for disk size and an attribute for memory. And then let's go ahead and import a method configuration for, wait, hold on. Method configuration, import. Runtime. There it is. And we see that the additional attributes that we added were disk and mem. Let's go to this method configuration. And we're going to say that the preemptible number of tries, let's edit this. We aren't going to use any preemption. Or maybe let's give it a try and see. So we'll say 1. The next item here is going to be disk size. So that should be this dot, I think it's disk. And this is memory. And so it will be this dot memory. And the output is going to be this dot runtime info. Let's make sure I got the attributes right. Mem and disk, I did. So let's go ahead and launch this. And we're going to go ahead and launch it on a participant set. So here's a nice example of how you can iterate a workflow across all of the entities in a set of entities. So we're running it against the set ACC. And to get it to, because the method configuration's root entity type is a participant, you have to sort of specify that you're running it against all of the participants in this participant set. And so you would say this dot participants. And we can go ahead and launch it. And here you can see that there were 5 participants in that set, and we're launching this workflow on each of those, and they're all queued. And I think I did the Julia Child thing already, so let me see if I can find the results. Runtime. Did I run it here? Yeah, I did. So here we ran it for each participant, and we stated each participant there were attribute values for disk and memory. And in this case, for example, we asked for memory of minimum of 4 gigabytes and a disk of 30 gigabytes. We can open up this file. Let me make this a bit larger. And you can see that the amount of memory was, we got 7 gigabytes, 7.6 gigabytes. That's because we required for a minimum of 4, and that's what was provided. And you can see that this right here is the mounted disk, and we got 30 gigabytes. Okay. So this is just an example of how you can use the method configuration or the outputs of your workflow to go ahead and specify what the runtime parameters are going to be. And there are some runtime parameters where you would want to be able to set them dynamically, and there are other runtime parameters that are very much tailored or geared towards the task that you're running, like the boot disk size. And in those cases, you might as well just hard code them directly into the WDL. Any questions about this? No. Okay. Okay, the next thing I wanted to do is just talk about file localization and delocalization. I've really discussed this already a couple of times, but it's important, so I just wanted to go ahead and throw one slide out there. As we said, that the way that the job execution service where we run these tasks on VMs operate is Jez will go ahead and we pass the Docker container a list of the URLs or URIs of the files that are on the buckets. And it's the responsibility of Jez to go ahead and copy these files down onto the local disk that is installed or mounted on the virtual machine. And then those files will be directly available to the task that is running on that virtual machine, to the application. Once that occurs for input files that are explicitly declared as input files. Output files that are generated from a task, if you don't explicitly declare them as outputs, then once the virtual machine gets shut down, that data is going to be lost. If you want to go ahead and save that data, then you have to go ahead and explicitly indicate it as an output parameter. Now, it may be that you want to save an intermediate output file, but that output file is not going to serve as an input to a downstream task, and that's perfectly fine. But you will want to go ahead and explicitly declare it as an output file. And when something is explicitly declared as an output file, then you have the option of deciding whether or not to write a reference to it back to the data model. Yes?
What happens when you're working with a tool that, for instance, outputs a directory of files that are not necessarily known how many files will be made?
Yeah, the way that we've worked around that right now is then you go ahead and zip it up and then write the zip file.
Yep.
Yeah, tar it up.
What's the speed of localization?
It's very fast. I don't know. I think, is Alex still? I think it's like seconds or something like that to go.
It depends upon the file, but usually it's negligible compared to whatever else you're doing.
So like 20 gigabytes and...
I don't know, like if you can copy a 20 gig file using GSUtil, probably 5 seconds. I don't know. Sometimes it's ridiculously fast. It's surprising how fast it can be.
It's as long as you're just moving files between components of the Google Cloud Platform. No cost. No cost, and it's really fast.
Well, you're going to pay for 2 copies if you've made 2 copies, but there's no cost to move things around. Like moving, I think there's a very, very small cost actually bringing it onto the VM.
Yes. Oh no, you don't pay for moving it to the VM. Really?
Very small.
So there is a localization cost.
But it's very small. I think it's like it has to do with some bandwidth stuff or something like that.
I wasn't aware of that.
Well, that's going to play in the decisions of how much you break up your processes, right? So if you have one file that's an input to a whole bunch of things, you don't want to have to make a whole bunch of copies of this, right? You instead want many processors that process.
That's true. Yeah, but if the cost is negligible.
Then you might go ahead and make.
Yeah. Right. Yeah, because there are benefits of introducing as much parallelism as possible.
And I suppose the overhead cost for, let's say you have a process that just does nothing. That's what, fractions of a second to spin up the VM?
It's not fractions of a second. I mean, the minimum turnaround time is on the order of like, they've reduced it a lot, but I think it's around like 30 seconds or a minute or something like that for just the absolute minimum thing you can do.
Oh,
Then it also has to be updated because Cromwell is monitoring it, and then we have another service that deals with the workspaces that's monitoring it. So it'll take longer to propagate, but it may be like for the smallest thing, might be 30 seconds.
And the cost of 30 seconds?
It's really, really small because we do this regularly when we're testing things in our dev environment, even with spinning, doing like 10,000 samples for a Hello World. It doesn't really show up in cost. It'll be, I don't know, a few dollars over the course of a month when we do that over and over and over again. I mean, it's very small. It's cheap.
Yeah.
We're also not requesting really expensive machines.
And the preemption, I mean, I suppose it could change by the weather, but how often does Jez job get preempted more than once?
Yeah, you plug it in.
More than once. I think that,
Thank you for
so
monitoring my level of
preemption, I
power.
know Genomes in the Cloud, they've done a lot with it, and they decided that it's around 3 makes sense, because it might happen twice, but if it happens 3 times, there's probably something going on, and you don't want to keep doing it because you're just wasting money. So it's probably not very likely to happen more than twice, unless there's like a,
No, it's good.
like I think the day that Pokemon Go came out, that used up like the majority of VMs in Google for a period of time or something, so that would have been a bad day.
So the reason something would get preempted has to do with capacity at Google.
Yes. So you pay less money because you're willing to put up with the fact that somebody might take it from you. And if it's a fifth of the cost, then you do it twice. Well, so what happens with the preemptables is you specify the number, like 2. It'll try 2 times, and after that point, it does it with the full cost non-preemptable VM. So at most, you're paying like 2/5 the cost plus the full cost.
Does the likelihood of preemption depend on the time of day?
I mean, it depends on what people are doing with.
Depends on seasonal effects too, I imagine. If around Christmas time, it may be more likely to be preempted. Yeah.
But I think you said that they were coy about, you know, when the best times to be running stuff were.
Yeah, they could. Try to game the system.
I know Google's they're just trying to maximize their resources. So there's some other things they're going to do besides preemption, like, I forget who was talking about it, but something about like, you can request a VM that's from a pool and you say, as long as you can run this within 24 hours, I'm happy. Then they can just allocate their resources however they see fit.
Okay, we're in the kind of home stretch here. I just want to discuss a couple of items here. One is some of the design decisions that you have to make, whether or not, you know, for example, in this particular case, we have a 3-step workflow, and you could potentially go ahead and call each of those steps in a single task. This is what we were talking about earlier, and you just have to decide whether or not, in terms of just price and performance, which is the preferable approach to take. Okay, right now we don't have job avoidance. We will hopefully in the near future, but this means that during development, what you might want to do is break up your say 3-step workflow into multiple workflows and go ahead and run each workflow independently. You save the results back to the data model, and then you can go ahead and run the final step. So in this case, say task A and B are pretty much well debugged. I know exactly what's, you know, they seem to be working well, but I'm having issues with task C. So what I would do is I'd go ahead and have 2 workflows, one that runs A, B, goes ahead and writes the results back to the data model, and then my iteration and testing only involves a single workflow that runs task C. So I'm not rerunning tasks A and B all the time. So this is just a kind of poor man's manual job avoidance that you might want to engage in during workflow development and testing. Okay. We already talked about this, preemptible runtime attributes, making the decision on what you choose to expose and set either through the method configuration or potentially dynamically through upstream tasks. I also wanted to talk a little bit about debugging task execution. We can just go to any of the tasks that we ran within FireCloud. Let's take a look at monitor, this one right here. This particular task. So each task generates a standard out, standard error, and jest log. And you can go ahead, well, this says there wasn't much going on in here, so it's 0. Let me look at maybe the mini mutation one, something that's a little bit more involved. here we can go take a look at the mutation detection task. It produces a standard out. You can go ahead and take a look at that. It also goes ahead and provides standard error. This is, you can look at it that way. That's the only thing that's written to it. And finally, and we find this very useful, it also provides a log that's created by Jez. And it's a lot of data there, and let's see if I can increase. But you can actually see references to the command lines that are used for localizing and delocalizing files. And it's quite useful for debugging purposes. So
you could make your own logging output file?
Yeah, absolutely. Yeah, you could do that. But this system automatically will will delocalize right to the disk the standard error, standard out, and Jez log. And it does that on a regular basis at 5-minute intervals.
And someone was asking on a related note about directories with variable numbers of files. You can have in the output usage of the globs, like star dot whatever, and so you can use the glob to just capture all the files, and it'll put them into an array of files using that glob. So if you have some out dir, and from 5 to 20 files in that out dir, you can say out dir files equals array file, or excuse me, array file out files equals glob out dir / star, and you can just get everything in out dir.
So that would be evaluated after the task completes?
Right. Yes. That's right. So the out dir would have to be created, and I guess if there's nothing in there, you'd have an array of length 0, but otherwise an array of length 1 or more.
That's for delocalization.
Right, for delocalization.
I got clarity too on the thing I was saying about it costing money to localize. It doesn't, but the VM is up during that time that it's localizing, and you are paying for that.
But that's probably a fraction of a second, or seconds, in order to go ahead and do the localization.
The data is,
Yeah.
but you pay for however long that takes
Right.
up VM time.
Yeah. Okay, but for any completed task, you will have links to standard error, standard out, and the Jez log. But you're still really operating in the blind, and that's where we wanted the ability to go ahead and SSH into these virtual machines, so you can really monitor what's going on directly on the VM in real time. All right. Okay, so I always want to get through. We'll do questions once I just make a couple of more points. All of FireCloud is developed open source, and so there are open source GitHub repositories that have the code for each of the microservices that constitute FireCloud. They're all listed right here. Excuse me?
Is anyone but us using it?
I don't know. Alex, are there any non-BroadE contributors to these repos yet?
I think that Cromwell team has got people contributing, or trying to contribute some stuff. I think that Whittle has maybe had some contributors outside. We haven't for the other services that I know of.
I know Sean Davis, one of the NCI evaluators, has expressed interest.
Oh,
and
okay.
I don't know if he's actually done it yet.
Okay.
If a user is not a BroadE Institute employee, or how can the billing get set up?
So in that, there's instructions in the forum to how to do that, but you'll need to create a Google billing account. And you provide through, I think there's either a web page and now I think where you can go ahead and provide that account. Or maybe you just send email to help at There's a Google form for that now.
But essentially the billing is done through Google, so BroadE wouldn't have to be in the
Yeah.
intermediate.
Exactly, right. But BroadE does need to create a Google project to which things on the cloud are charged to must be associated with the billing account. You'll have to provide us with the billing account, and we will link it to a Google project that we own, that FireCloud owns.
There's still the issue of us paying for anyone copying data.
If somebody, if you have a project that is linked to your billing account and you create workspaces for that, just be careful who you share that workspace with. Because if you share it with somebody and they, even just as a read, well, if you share it with somebody and give them write access, then not only are you paying for their ability to download data, but they can also run analyses within that workspace. If you share it with somebody just giving them read access, they're not going to be able to upload data or run analyses, but they will be able to download data, and you will be charged for those data egress costs.
It's a big problem that we keep pushing Google on. They are going to have solutions for that soon. It's probably going to be a model where the downloader can be charged for downloading it. We'd like to be able to have the ability to just stop downloading altogether, but charging it to the person that downloads it.
So if you create a base workspace that's empty of data,
Yes.
then when somebody clones it, do then they incur all the charges now?
Yes, well, it's because if they clone it, then their clone, if it's a base workspace, and when you create a workspace, there is a bucket associated with it. If you have no data in that bucket, or your data model has no references to that bucket, then when they clone it, their data model isn't going to have any references to that bucket, and they're not going to be able to download that data.
The only thing you pay for is actually the bucket storage and the compute. None of the stuff that you see in terms of data model or workspaces, that doesn't incur any charges.
Right.
We host that stuff.
Right. So the only time that you will potentially be charged for the egress charges for somebody who cloned your workspace is if your data model, if the data model that they cloned has references to data in the parents bucket. Yeah. Okay, lots of FireCloud resources. These are all links. We also have an active forum, and this has been a big collaborative effort within the BroadE. There's our group from the GAD Gets Lab, myself, Eddie, Gordon, Megan as project manager, and Jason. Then most of the development itself has been by the DISD KDUX organization. Long list of people involved in it. Alex is the DISD product owner for that. With, as I mentioned, this is a FISMA moderate system, so we work closely with the BroadE security team in helping us get FISMA accreditation. And also we've done some collaboration with researchers at UC Santa Cruz and UC Berkeley. Okay, so now we can we have about 20 minutes left. I can open it up to questions.
When you create a Docker image that's got essentially copies of software that programs that we've built, right?
Yes.
That basically then gets run by whoever imports the Docker image.
Yes.
Is there, I presume we don't do this, but is it possible for there to be some sort of royalty fee or licensing fee collected at the time of execution of the Docker image?
No, not right now. But what we do want to do is collect statistics on the usage of other people's Docker image.
The question in terms of could the BroadE do it? What I wanted was can it be done so that Google collects the money for you?
Oh, that I don't know.
Google's already collecting money for us. I mean, what do you mean? They're collecting money by virtue of the fact that you're paying for their VMs and stuff. But
yeah, but this is for licensed tools.
So the BroadE for people who use the BroadE developed program.
Sure.
Okay, but I would presume that there are other commercial entities who do want to do that.
Yeah. Yeah. I mean, we don't have any needs that have come up, and we usually have open source tools we provide to the community, so there'd have to be a good reason to support a model like that. I think in general, we would rather make that not the case and push the community to not have tools that you have to pay for.
Right, and remember, this was developed under a grant or a contract from the National Cancer Institute, where it was intended to be.
You know, you look forward, what if the grant doesn't get renewed, right? You know.
Well, even, yeah, it's a system that isn't just being used for the NCI Cloud Pilot project, but it's being used. There are several stakeholders now within the BroadE Institute who are using this system, including the genomics platform. One thing that I didn't mention is that when you add your Docker image to Docker Hub, it can either be a public image or a private image. So you might develop a tool and you want to run it on FireCloud, but you don't want to make it available to others. And you can go ahead and do that. You can sort of publish it to Docker Hub as a private tool. I think you will have to pay Docker Hub. There is a fee associated with that. I think I think an individual user who has a free Docker Hub account is only allowed a single private tool. But if you want to have multiple tools, then you will have to pay a fee to Docker Hub for maintaining multiple private tools. But then those private tools can be accessed and used within FireCloud, and it'll be up to you to make sure that the WDLs that you write that reference those tools are only shared with the collaborators that you want to use those tools. Okay. But to make a private tool available to FireCloud, you need to go ahead and share that tool with a FireCloud Docker Hub account user. Okay. Other questions? No? Last chance? Okay. All right, well, thank you very much. I know it's been a long day.